When the light is green, the trap is clean, right? I want to see how many people still remember Ghostbusters, right? So how many people have legacy software? How many would say that the trap is not green? All right, so we're going to talk a little bit about ways that a method that can actually improve that, and then how to track it. Okay, so the way we're going to improve that is the Mikado method. I don't know if anybody's really heard of the Mikado. Has anybody read anything on the Mikado method at all, other than David? A little bit? Okay. And then we're going to also talk a little bit about how to track that, the progress of the work that you're doing inside of Kanban. I'm going to spend more time on Mikado than Kanban, but I do have time for plenty of questions and stuff like that afterwards, and hopefully, we can answer anything like that. The Mikado method its name comes from a European game, even though it's a Japanese word, thank you, called the Mikado game. And this particular game we call pickup sticks here in the United States. The rules are a little different in that in the European game there is a singular stick called the Mikado, the Emperor, that you're trying to get to that has the most points, right? And if anybody's ever played pickup sticks, when you try to pick up one stick, it tends to affect all the other sticks in some negative manner. And that's sort of like when you have some kind of large architectural change or a large bug that has a large architectural change behind it. You try to make that one change, and next thing you know, you're playing whack-a-mole, right? Trying to stamp out all these different bugs all over the place, and you go stamp out one bug, and a bunch more show up. And this Mikado method is designed to try to get rid of that problem, to try to help you think through the problem in a methodical manner, right? So what we want to try to do is understand a little bit about how we can make these changes and make them safely to our legacy code, make these large architectural changes, and do that. So there is one huge difference that we have between the Mikado game and what we can do with software development and code in particular. And that biggest difference is we have a source code repository that allows us to revert our code, right? So we can actually go back to something. So we can make a change, see it break a whole bunch of things, and then we can say, ooh, I don't like that, it's revert, and I'm back to a safe spot. And we're going to take advantage of that safe spot when you'll see when we start working through the method, right? That's very, very key. If you do not have a good source code repository that lets you go back to a safe spot, that's a big assumption that's under this whole method. All right, so if you don't have it, you shouldn't be trying this method, probably any other method. So you need to have that in place. The other thing you want to have is something as close to the environment of what the problem you're trying to solve, right? Sometimes that means a production-like requirement, and sometimes it means something a little less than that. But the closer you are to the production, the more chances you won't have a mismatch. Because the last thing you want to do is go fixing something in a system, and it then changes into it doesn't show up in production, right? Particularly when we start stamping down to the smaller pieces that we're going to get to. All right, so let's get into the guts of the method. So the guts of the Mikado method, and there's what's called the naive approach, and that's what we're going to talk about first. And then we'll talk a little bit about when we have tests involved and so forth. So the naive approach means I have no tests whatsoever that I can count on for helping me, right? So the first thing I do is I'm going to make the one big change that I want to make. Whatever architectural change, whatever defect that I'm trying to solve, whatever it is, I'm going to go ahead and make that one change. It's going to break a whole bunch of things, all right? So, and I expect it to break a whole bunch of things. And I'm going to see what broke, and I'm going to then visualize these. These are prerequisites. I need to fix all the prerequisites before I actually start running off and fixing, fix those prerequisites before I fix the big one. However, I don't want to run off and fix those other things when I'm not in a safe spot. So after I visualize them onto a graph, all right, it's going to look sort of like a hierarchy that's growing outward. I'm going to revert my code back to a safe spot. Then I'm going to pick one of those prerequisites, and that's the next biggest thing I want to do, and I'm going to make that change. That might break a whole bunch of things. I'm going to then visualize that onto the graph. Then I'm going to revert my code again, right? So I'm always going back to a safe spot. When I eventually get to a leaf node, as we see, something that I can change and it doesn't impact anything, I can go ahead and commit that code. And I can start working back from my leaves backwards until I get to my final big change. So let's take a look at how this might look. So let's suppose I got a content management system out there, and I want to decouple the server that does the content management into both a publish server and an edit server, perhaps for scalability, perhaps because I want to put one on one side of the firewall, one on the other. Doesn't matter what the rationale, but that's the architectural change I would like to make. Right? Does everybody follow me so far? All right, cool. All right, so as I explore outward toward my leafs, I'm doing some discovery. All right, so I'm going to go out and do some discovery. So the first thing I might do is when I try to make this change, I might say, ooh, I need to have a standalone publish server. Well, that's pretty logical. And I need to remove my publish methods from what now is my edit server. So those are things that I need to do. All right, so great. I'm going to, now that I visualize it, I'm going to revert my code, and I'm going to explore one of these leaf nodes. Great, I'm going to go off, and let's talk about trying to create this publish server. So I start standing that up. That's great. I have a bunch of other things that pop off of that sort of break. I've got some approval logic that's not working. I wonder what's going on there. I've got some deployment properties I need to change. So I need to do that, and perhaps I'd like to now separate my storage interface out. So those are things that I need to do that may be breaking, right? So I'm now going to start exploring one of these other leaf nodes. So I'm got them visualized, I revert my code, and I say, let's run off and do the separate approval logic piece, right? And I find two more things break. I've got a bunch of permission changes I need to do on how I check them, and I need this publish reject code needs to get in there to make it work. So I'm going to go ahead and now revert, graph them on my thing. I'm going to revert my code, and now I can start exploring one of those. I could either start exploring these leafs, or maybe in my case, I'd like to explore one of the other ones. So I take a look at change deployment properties. It's okay, all right? It doesn't look like there's anything else that I can see at this particular point in time that I need to change. That's fine. I could go ahead and make that change. However, I'm a little worried about the storage interface, so I'm going to take a look at that real quick. Oh, it also has some deployment properties that need changing. And I need to re-implement my database interface. So these might be the things that I need to change now, all right? So I'm going to now start exploring. Let's go back to this user permission one. All right, and as I start doing this, if I hit leaf nodes, I'm now starting to refactor backwards. All right, so I'm going to start refactoring backwards. Joe Yoder mentioned earlier in the session about big ball of mud. This is really useful for the big ball of mud because I'm now starting to visualize what's inside of the big ball, right? Or the hairball might be a better way of saying it. This stuff gets all tangled in there. It looks like a hairball, right? So I was able to do this okay. So I go ahead, make my change, check in my code. I can check that off my graph, and I should be checking this off. If I'm going to literally use this as a visualization technique, which is what you want to do, it's not trying to make it so pretty. You want it on one of those things, right? So it can be up in the team's workspace that's working through this problem. And they can actually check it off and say, that's done. We don't need to revisit that anymore. Again, I can now start moving through the next leaf node. Okay, I could go ahead and handle this publish reject code. I now know everything that I need to do about my deployment properties, so I'm going to go ahead and make that change. Nothing else broke. It's safe to commit the code. I can actually go and do my approval logic at this point. Why? Because I have both my prerequisites. I didn't have to do this first. I could choose to do it first. It's really just a matter of decision. As soon as I have my prerequisites done, I can start moving down the graph, which can be very helpful because I could go out here, found these, and then go off on this one, go to these, fix these, come back to here, and then start exploring that side of the tree, right? It doesn't really matter the order, as long as I can visualize the paths I'm going through the caverns as I try to figure out how to shore them up, all right? So those are the things that I want to do. And again, I could re-implement my database interface. Now I'm safe to go ahead and do my separate the storage. Lastly, I could move into my standalone. I can go off, take a look, remove my methods, nothing else broke, and yay, verily, I can decouple my two systems, and I'm done. All right, so that's sort of the guts of the naive method. I'm counting on things breaking. Now, a couple things to think about if this was driven by defects. All right, so if what I was doing there was just a pure architectural change, but if I was being driven by, let's say, a large-scale bug that came in, all right, I probably want to try to use exploratory, and if I have regression testing in place, use that to help that discovery, right? That will help me find things that are breaking that maybe wouldn't be found just by pure observation, right? That might be very difficult. The compiler may not pick up on certain logic problems that may get introduced by just starting to make changes. So having those in place is very helpful. Likewise, if I don't have things like unit tests in place, I probably want to start thinking about wrapping unit tests in this as I'm going through my code, particularly if I'm down at the leaf nodes, right? Because those are smaller changes, less likely to be picked up. If I end up changing code later on down the pike, I'm less likely to pick up those things. That's why I would like to have tests in place when I'm doing this, because again, if it's a logic problem or something like that, it's not going to get picked up. And then of course, if I'm going to do this testing and rely on this, I want it to be as close to production as possible in an environment, just to make sure I'm handling things, that might get stepped on if I'm doing, scaling or something like that. All right. Now, the real power of Mikado comes when I actually have a lot of tests, right? Instead of changing the one thing and seeing what breaks, it's change one thing and see which tests fail, right? If the tests went from green to red, I know I've got a problem. And now I can investigate the problem and start associating the things on the graph to what's on the problem side, all right? And that will help me reveal what kind of refactors I need to do, right? So I can start doing my red, green, blue refactor type thing. And finally, it will also give me a safety net for other breakages, right? I can know when I change this, it's not a matter of just seeing what gets coughed up by the compiler or something like that. I actually can see the test failing and know, hey, here's the area of code I need to go check, right? And then I can, start debugging what the logic problems are. And again, really big deal if you have integration tests. That can help you figure out those problems where, APIs are talking to one another and all those kinds of things. So let's talk about a few things when we get into this. When we're starting to talk about refactoring, there's a whole bunch of factors that go into it. I've separated 3 that are specifically mentioned in the Mikado method book. One is I want to add some functionality to a system, and that's going to drive some architectural change. And so I want to do the refactoring before I start adding that in. And this is very helpful for seeing and graphing this out. And we're going to look at that particular instance in just a minute in a very simplified manner. I could also just want to separate bulky interfaces. I'm starting to get too many consumers, so I want to split those out. I want to understand what kind of negative impacts I may be having. Again, the Mikado method can really help out in that regard. And lastly, I might want to be taking a look. I'm seeing some common methods and classes that I'm using, and I want to break those out into a library and reuse those. So again, if I'm breaking those out, I need to think a little bit about how those get handled. And again, the Mikado method can help me figure through those a lot faster. Again, primarily because of the visualization technique, right? So here's one where just a very simplified model of wanting to add some functionality. I want to add a game called War to my card game engine, right? Currently, it does 5-card poker and Indian poker. And right now, this particular stuff, I'm just showing a little bit of if-then-else logic that says what kind of cards need to be dealt depending on the card game. So I could certainly add another, else clause and say War deal 26, right? That's probably not a really good answer because the next thing I might want to add is blackjack, and then after that I might want to add another card game like Go Fish, right? And then I eventually want to add something, I don't know, whatever other game, Rummy, for example. So this is not really looking like a good approach for me to do. It would be a whole lot better if I started separating these things into card game classes. So if I were doing the Mikado game, the big change I want to do is add the War card game. But now I'm starting to see enough instances that I want to refactor my code. So I want to implement the War logic into a class, but I need to refactor the if-then statements to get classes out. And so again, my Mikado method would look something like this. And then of course, once I go up to here, there may be other things that would spit out above that, and that would be developed on tests and stuff like that. So this is, again, just a nice way to visualize how I'm going to refactor something, even though it's hey, I know exactly what I want to do from the big picture item, and I kind of have a big picture item of the things I need to change. What things am I going to break? What are the offshoots by breaking out the Indian poker logic into an Indian poker class? I might not fully understand that until I start breaking things and seeing what tests are failing and so forth. Does that make sense to everyone? All right, so now let's talk a little bit about how we can understand how long it takes us to do these kinds of things. How many people have worked with Kanban? Okay, so for the folks that are not familiar with Kanban, Kanban is a visualization technique. It comes from the Toyota production system. Kanban literally means signal card. All right, so In the Toyota production system, you know, if I'm working on an assembly, I put a signal card on it that tells the next work center that they can pull the work over to start working on it. All right. I don't pull it until I have capacity. I finish whatever item I have, I put a signal on card, and the next person pulls that. When they pull it, I pull the next item. And that way I limit my work in progress, right? Because I want to limit that because that helps me get smooth flow. So in software, we can't really visualize and put a signal card on our code, right? We could tag it and all sorts of things like that, but that's not very visual for figuring out when I want to pull it. So we represent it on a board. We abstract it, put it on a board of whatever our particular assembly line development process looks like, and so now we're dealing with the items. So I've come up with a notional board that you could use that complements the Mikado method, right? So the idea is to find a particular one that would complement that. And it should be based on your work process. So in here I'm assuming sort of a TDD approach, where I might want to, I might have acceptance tests or stuff that I might want to update when I'm making the changes. So I've got my Mikado graph. I still want to have my Mikado graph. That'll help me figure out things. And the first item I've got in is, down here, and I've also put it in my intake, all right? And so the first thing I need to do is figure out what things need to be fixed. So I'll bring it over into a triage. One thing I should mention, the other thing, limiting work in progress becomes limits on your column. How many items do you allow in a column? In this particular notional system, I'm going to only have one item in here because I'm going to assume it's a very small team working on this. However, if you happen to have a larger team, you may say, well, I want one item per update test, one item per fix, one item per retest, or maybe several items if I have depending on the size of the team. Likewise, my done columns, which are sort of cues for the next state, I want to also have those same work process limits. So the things I would assume that would have work in process limits based on that would be ready through done of retest. Those would be the items I would think would have it. Maybe deploy if I'm doing sort of a DevOps type of arrangement, because I might only be able to handle deployments at in a certain amount also. My triage and my intake, probably not, right? Intake is whatever I'm receiving, and triage is going to be whatever breaks out of this analysis. And depending on how I decide to do that, could do that. In this particular way, I'm going to say I'm going to try to break things out as far as I can, and then I'll start prioritizing and putting them into ready. So I've got my one big item. I go ahead, make my change, see what failed my tests. I got a couple items out of that. Put those as 2 new items on my Kanban board, so I know how to manage those, revert my code. All right, now I start investigating down the tree. All right, cool. I picked up another 2 items. Well, not so cool. I really would have preferred not to have had leaf nodes at that point, but I picked up a couple more items, added to my Kanban board, make sure they're on my graph, right? Revert my code, and then of course I pick up a couple 2 more when I investigate that side, and then finally pick up another one when I go that side. So we get a feel for how things kind of lay out. Now I've got a backlog. I can start pulling over the items that are at the leaf, right? Start pulling those over, and I can prioritize my leaf stuff. So for example, if I'm going to prioritize that I'm interested in dealing with the stuff on this side first. For whatever reason, that seems to be the most important things to be handling. Again, especially if this happened to be an architectural change where I'm trying to figure out features, I should be driving what's going to get me to the feature fastest and what's it has the right amount of risk management to it, right, to prioritize these things. And then, like I said, I'm going to run these things through, update any tests that I need to do around. If I'm adding functionality, I might be updating acceptance tests. Maybe I'm adding some additional regression tests, whatever. And then I can finally get around to fixing it, right? Then it'll be done in there, and then perhaps the folks pick it up and they retest, right, and make sure it's done. So in this particular case, and I can do the same one, and I've got to make sure I check off my Mikado graph too. Pull the next item over and do this same thing, right? Same basic workflow process to get me through to done over here. And once I've done that, I now can pull over this next item that's down below, because I've gotten rid of the prerequisites. I can now say that it's ready. So that can be an entry criteria for things that go onto the ready column, right? Because I want to think about entry criteria and exit criteria when I'm using Kanban, right? Things that have entry criteria are things that I can pull. you know, that if they've met the entry criteria, likewise, things I can say are done are things that have met an exit criteria. So in this case, my entry criteria is I've handled all the prerequisites. That's pretty much it. Oh, my Japanese did show up. So arigato. Is there any questions or anything anybody has? Yes?
Wouldn't it be easier to do this with mocks instead of commuting the word interface?
Doing with mock data or mock interfaces?
Mock both. Instead of changing the whole thing, you just create a mock or create another mock. And then
Sure.
those mocks one.
So you could probably put in the mocks as part of the Mikado as well. I mean, there's no reason why you couldn't, right? See how it works with the mock. But however, knowing what it works with real code, not the mock. You know, so the mock would be more how it's intended to work. If it's not working with the real code that the mock is taking the place of, then
Use mocks to find those loops.
yep.
And then anyway, you need to.
Yeah, so that might be a good way of figure out what the gap needs to be, right? Entering some mock will certainly help me if I want to then add unit tests and stuff like that in with it too, right? So that's a good point. Yes?
What happens in your discovery step when your chain of breakages is a cycle?
So that shouldn't happen, right? Certainly, because of course this is complementary to other things like cyclomatic complexity and so forth. So having some kind of graph. The graph here should not show up any cycles. They actually discuss that in a particular chapter, right? You shouldn't have a recursion that's showing in this because this is all about changes you're making, not necessarily the code that's happening. So one of the changes might be to get rid of the cyclic reference that might be in there. So.
Yeah, I was going to say about that, I think it might also be that your hypothesis as to which you need to change
Could be
wrong in that.
that could be
Hypothesis
exactly. So I thought I would need to change this, and it's really a cyclic reference of some kind. That's that's what I need to change. Right? Any other questions?
So in Agile, they use Scrum and Lean board. How this is different from the board?
So there's a couple different things. So Scrum, as a task board arrangement, usually it's just a to-do, doing, and done. Sometimes you change and also have tests or something like that. Hopefully it doesn't look like a waterfall. Kanban is a flow-based system, so I don't have iterations. I could use it within an iteration. That would be called Scrumban for those people that care. But a flow-based system, I'm interested in. I didn't really get into in details. I'm interested in lead time. So how long does it take me to fix one of those little items down at the leaf, and how long does it take me to get done with an architectural item down at the bottom? And understanding the differences in lead time when somebody comes along and says, hey, I've got this change, and you're going to go, ooh, that's architectural in nature. The complexity says, here's my lead time for that, because I've been measuring it the whole way. And if you have a pretty good software system like LeanKit, for example, you can get a good measurement of what your lead time is. And it shows up in what's called cumulative flow. Right? You want to understand your distribution as well, right? That lead time is not going to be constant. You're going to look for the average and the standard deviation, so you can then do predictability on it based on that. Does that help? Any other questions? Cool.